Okay, the title says find real or complex zeros of polynomials with degree n greater than 3. Because if it's n equals 2, if the degree is a 2, it's a quadratic, and we know how to find the roots of quadratics. If it's a third degree, we just use factoring by grouping, and we can do that too. But when it becomes a larger degree, it gets a little more complicated. Does everyone have a graphing calculator? If you don't, please come get one. Yes? No. Guys, it's the same temperature it's been all year. Okay, essential question. I don't like that, sorry. Okay, this is level 1, but it'll do. Explain how to find the zeros of a polynomial with degree n greater than 3 when you're not given any zeros. Sometimes they'll give you a 0 to start you off, but other times you won't be given any zeros and you just have to figure out how to start it. Okay, example 1. We're just going to do probably 2 of these. Example 1. Find all zeros of f of x equals x to the 5th power minus 3x to the 4th minus 5x cubed plus 5x squared minus 6x plus 8. And we're going to write linear factorization. I've been saying this phrase today a couple times. Linear means it should be x to the 1st power. Factorization means we write out all the factors that are x to the 1st powers. All right, can we do the x box method on something that says x to the 5th? No, can we do factoring by grouping? Oh, that really only works with x cubes. Okay, so here's where we get stuck. Sometimes they'll give you one of the zeros to start you off. If you're not given any zeros, then your best bet is to graph it and look for what looks like an x-intercept, and then we verify it through synthetic division. So would everyone grab your calculators, please? The what? It's from the same honor section. It's from H6 again. Okay, get your calculators. We're going to type all of this in to y equals. Open up your calculators, please. Oops. Where's my... Is this working? There we go. All right. Erin, can you read off our polynomial? Did you write it down? No. Okay, Kayla, can you read it off for me? What should I type into my calculator?
X equals x to the 5th minus 3x to the 5th minus 5x to the 3rd plus 5x squared minus 6x plus 8.
Okay. You just type that in, the same polynomial that we put on the example. Then we're going to graph it, and we're looking for the x-intercepts, because those will be zeros. And then we'll verify them through synthetic division. Okay, does everyone have that typed in? So it's x to the fifth minus 3x to the fourth minus 5x to the third plus 5x squared minus 6x plus 8. Now, let's make sure everyone's windows are the same. I'm going to go to Zoom Standard, number 6. Zoom, number 6. And we're looking for what could potentially be a root. What does that one look like? Negative 2. What does that one look like? 1. And what does that one look like? 4. So we're going to try those ones. Can you write those numbers down? X equals negative 2, 1, and 4. These are potential roots, but we need to verify them. Potential roots. X equals, what do we have? Negative 2, 1, and 4. Okay, we're going to use synthetic division to verify them. So, since it's already a root, we don't change the sign. The root, or the 0, or the x-intercept, goes in the box with the same sign. Then synthetic division, this is one of the long ones, but we just take all of those coefficients and put them in order. 1, negative 3, negative 5, positive 5, negative 6, positive 8. Is that good? Leave a line of space. And even though there are lots of terms in this, we just follow synthetic division carefully. Okay. So we bring down the 1, and what do we do with 1? Multiply it by that negative 2, which will make negative 2. Then I add up my columns. Negative 3 minus 2 is negative 5. Now what do I do? Multiply by negative 2, which makes positive 10. Add up my column. What do I get? 5. 5 times negative 2 is negative 10. Add up my column. 5 minus 10 will make negative 5. Times by the negative 2. Diagonals are always timesing by this guy in the box. Negative 2 times negative 5 will be positive 10. Negative 6 plus 10 is 4. 4 times negative 2 is negative 8. 8 minus 8 is 0. What does this tell us? That it is a real root. So we found one. I'm going to put a check mark. That means it works. X equals negative 2 is an actual x-intercept. Okay, this polynomial has now become, let's practice writing this out. This is the remainder. Constant, I think it's easier to go right to left. Constant is 4. What's the x? Negative 5x, then what comes? Positive 5x squared, then what comes? And then lastly, I think it's just 1x to the fourth. Okay. You got all the other ones though. Look what's happened to the power. It started as an x to the fifth. When we divided, what happened?
It went down.
It stepped down. So if we divide again, we'll now get a cubic. If we divide again, we get a quadratic. If we divide again, we get a linear. Okay, each time you divide on the polynomials, the degree should be decreasing by 1. Okay, we verified -2. Now we're going to verify 1. But you don't have to use the long x to the 5th synthetic division. We can now use our x to the 4th. I'm going to make a new box. Put my next 0 in. My next 0 is 1. I've tried -2. It works. Now I'm going to try number 1. And actually, on this line, we have all of the coefficients, or you can look here. Either line gives you them. I'm going to write them out. 1, -5, 5, -5, 4. We do synthetic division again. Can you do that by yourself? Work on the synthetic division. We're using now the x to the 4th power. Add the column times the diagonal by the box. What are you hoping to get at the end? A 0. If you don't get a 0, I would carefully check your work first. And then, if you don't get a 0, then that means this is not actually an x-intercept. Do we get a 0, or do we get something else? Get a 0. Audrey, put up, please. Okay, really quickly, bring it down. 1 times, we get 1, add -4 times, we get -4, add times -4, multiply, -4, 0. Cha-ching, right? So this is a confirmed 0, x-intercept. Now we have a constant, a linear, quadratic term, and a cubic. So now instead of a 4th degree, it's now a cubic. Whoops. We have one more to verify. What was the last one that we saw on the graph? +4. Now you don't have to, you can go back to x to the 5th if you want, but that's a lot of work. You can use these numbers we just found. And you don't need the 0. 1, -4, 1, -4. Do synthetic division again. Once we get down to a quadratic, if you like synthetic division, you can continue with synthetic division, or you can use your factoring skills. It has to be down to a quadratic, and right now we're at a cubic. Add up the column. Come on, Audrey. Okay, what did you get for your numbers below? 1, and then there's the 0, right? And then a 1, remainder 0, which is good news. So we verified all 3 x-intercepts we saw on the graph are in fact true intercepts. So this becomes, the constant is 1, the x is 0, so I don't have to write it, and that is an x squared. Once it's a quadratic, you can continue synthetic division, but we don't know any other zeros to try, or you can use your knowledge of solving quadratics. If we're looking for zeros, we put it equal to 0. How do we solve the quadratic? You could find the factors doing the x box. That's an option. You could do quadratic formula. This one happens to only have one x term. The fastest way to solve this one would be square roots. Can't I just subtract 1 over? And you have x squared equals -1. How do we get rid of the squared? Square root. Now we get x equals plus or minus, make sure you realize there are 2, square root -1, which we should know what square root -1 is. So we have plus or minus I. These are conjugates. They have to come in a pair. One is a positive I, one is a negative I. So we found 1, 2. Here's 2 roots. 3, 4, 5 roots. Remember the fundamental theorem of algebra? Any polynomial with degree n has to have n roots. This is degree 5, and we found 5 roots, right? So it should be even. So let's list out our roots, or our zeros, which are also our x-intercepts. We have x equals -2, 1, and 4. And what were the other 2 we found at the end? Plus and minus I. So there are, in fact, 5 of them. Okay? We're going to try one more like this, and then we'll go take a short little break and go to a review. Same directions. Well, yeah. But this time, one root is given to you. The complex number z equals 1 minus 2i is a 0 of f of x equals 4x to the 4th plus 17x squared plus 14x plus 65. Find the remaining zeros and write it the linear factorization. So same directions for the rest. Find all zeros. Oh, we didn't write the linear factorization on the last one. We'll do it on this one. Yes. Okay, so it gives you a hint. It gives you a start that it tells you one of the zeros. Let's look at the graph, see if we can visually find another x-intercept. So go back to your y equals, clear out. I'm going to have to rely on Kayla again because I can only see one screen. Kayla, can you read off what it was?
4x to the 4th plus 17x squared plus 14x plus 65.
Thank you. Okay, 4x to the 4th plus 17x squared plus 14x plus 65. Okay, if we graph, you don't see anything because those are pretty big numbers. So if you go to zoom, you have some options. You can zoom out. There's also a thing called zoom fit that sometimes I like. Sometimes I like it better than the zoom out. It's the 0. Interesting. We're looking for x-intercepts. I'm going to look at my window. What is my y-axis on? Y minimum's at 62. I'm going to put y minimum at 0, counting by, wow, 41,000. Holy cow. Counting by, oh, maybe 5,000s. Interesting. It looks like it just skims the bottom. It probably touches. We'll have to verify. Can you tell exactly where that would be touching? What? Well, maybe, yeah, it looks like there's an axis of symmetry, because anything to an even power will look similar to a parabola. So maybe 0, we're not sure. We'd have to verify that. But we do know one for sure. We do know this complex number is a 0. But all complex numbers come in pairs. So even though they only told you one, you should know a second one. Yeah, remember on our notes the other day, we wrote the conjugate as z bar? What's the conjugate going to be? Uh-huh. Okay, so we have 2 of them to use. Okay, using synthetic division, we're going to start with the first one that they give us. 1 minus 2i. Now when we set up the synthetic division, be careful, we have some gaps. X to the 4th power's coefficient is 4. What's x to the 3rd power's coefficient? 0. It's not there. 0. X to the second power is present, so it's 17. X to the first power is 14. And x to the 0 power is 65. Brian? Sit all the way up, please. Thank you. Okay, now this is a little tricky. If you make sure you have some space, since we're dealing with a complex number, make sure you have some space. It's not all squishy. Synthetic division still follows the same directions. Carry down the 4. Now what do we do with the 4? Yeah, and we get another complex number, right? So it's now going to be 4 minus 8i. Okay? We add up the column. This is a real number, 0. So we add it up and we get 4 minus 8i. Now we multiply that complex number by this complex number. Oh dear. I think I need more space already. I'm going to put 65 out here and 14 out here. Okay, 1 times 4 is 4. 1 times negative 8i is negative 8i. Negative 2i times 4 is negative 8i. And negative 2i times negative 8i is positive 16i squared. I think I heard negative 16 out there, but this negative times negative would be positive 16i squared. Okay, and what happens? We have, this becomes negative 16. We have like terms. 4 minus 16 is 12 minus 16i. So now I'm going to add it up with the 17. But 17, does it add to the 12 or does it add to this negative 16i? Yeah, because it's a real number. So the real piece plus the real piece. 17 plus 12, yeah? Oh, yes, thank you. It is negative because that was a negative 16. Good catch. 17 minus 12 makes 5. Minus 16i. Do it again. Okay, I'm using parentheses to help try to separate these columns. We're going to multiply this complex by the complex there in blue we just got. 1 times 5. 5. 1 times negative 16i. Negative 2i times 5. Negative 2i times negative 16i. Positive? Isn't it positive? Negative times negative, positive 32i squared. Looks like I still need to move the 65 over a little more. Okay, finding like terms. We have the i's. And this will become what type of 32? Positive 32 or negative 32? Because I squared is negative 1. Negative 32 plus the 5 is negative 27 plus the 14. What's the gap between 14 and 27? So we'll have negative 13, and our ice cream's negative 16 ice creams minus 10 ice creams is negative 26 ice creams. Okay, one more time. Negative 1, or positive 1 times negative 13. Negative 13. Positive 1 times negative 26i. Negative 2i times negative 13. Negative times negative will make a positive. Oh, I skipped. I didn't do the 1 times. No, that's right. Negative 2i times negative 13i is positive 26i. Yay! Cancel, cancel. How nice. Negative 2i times negative 26i is positive 52i squared. Okay, guess what? All of our i's are gone because this 52i squared is actually a real number. Negative 52. Negative 13 minus 52 is actually a negative 65, which makes a 0. 65 and minus 65 make a 0, which tells you they weren't lying. They said that that was a root. Turns out it is a root. Okay. Now we have a conjugate. The conjugate was 1 plus 2i. Let's do it one more time. Leave some space. We have a 4. Make sure we've learned we have to leave a lot of space. 4 minus 8i. I'm just taking these things we found last time, the new coefficients. 5 minus 16i and negative 13 minus 26i. The good news is this is the last step of the synthetic division. Okay, bring the 4 down. This is absurd, is that what you said? Okay, bring the 4 down. Times it, we get 4 plus 8i. Oh, that's nice. Look how nice that is. Because what happens? The i's cancel and we get a real number 8. Oh, that's pleasant. We times 8 to our complex number. We get 8 plus what? 16i. Oh, this is pleasant too. Look what happens. Oh, snap. Cancel, cancel. How nice is this problem? The first step was awful, but this step's pretty nice. 5 plus 8 is 13. Lastly, timesing 13 to our 0 out here. 13 times the 1 is positive 13. 13 times the 2i is a positive 26i. And what happens? Everything cancels, we get remainder 0. So, let's see what polynomial this creates. Remember, this is a remainder. This is a constant. Plus, what is the 8? That's a linear. What is the 4? Once you get to a quadratic, you can keep going with synthetic division if you like synthetic division. Or you can solve the quadratic with other methods that we've learned. We can't do square roots on this because there are 2 terms with an x. How can we solve this? You could try an x box. I'm going to tell you right now it doesn't come out as real numbers. So you can try that. If it doesn't work, then your next thing would be, yeah, our quadratic formula. What is A? 4. B is, C is. Okay, let's sing the song. How does it go? It's negative B plus or minus square root B squared minus 4AC all over 2, what? 2A. Okay? The hardest job is simplifying the square root. What's underneath the square root? Did you grab that number for me? Remember, if it's greater than 0, we know we get 2 real numbers, real solutions. If it's less than 0, we get 2 imaginary solutions. If it's equal to 0, we have 1 real solution because there's a repeat. What do we get for the square root? Okay, root negative 144. Since it is negative, we are expecting two imaginary solutions, which is why the factoring wouldn't work. Okay, equals negative 8 plus or minus, what's the square root of negative 144? Plus or minus 12i. 12i over 8. Okay, so there are going to be two answers. I'm going to first break this up. The real piece is negative 8 over 8. What's the imaginary piece? 12i. Now this is the part lots of people forget. You said it correctly, but lots of people forget. 12 is over 8 still. So we have two answers. Negative 1 plus, what does 12/8 simplify to? Divide by 4 on both. 3 over 2i. So we have the plus version and we have the minus version of that. Those are the zeros. Let's write the linear factorization. We found 4 zeros, which makes sense because it was an x to the 4th power. They gave us 1. We knew another one because of the conjugate. And we just found 2 more using the quadratic formula. Okay, so linear factorization. Okay, we have f of x equals, if this is an x-intercept, how do we write it as a factor? That's an x-intercept. How do we write it as a factor? There's 2 of them, right? And we have a minus 1. So the factor has to have a different sign. So if it's minus 1, we would say plus, I'm going to put it in a grouping, 1 plus 3/2 I. Okay? Oops, I missed the negative. It's still a negative 1. But it's adding that factor. And then we have another one, which is the conjugate version, minus negative 1 plus or minus 3/2. Ooh. I still have the I? Yeah, sorry. Yeah, sorry. You are correct. Minus. Good. Okay, and the other one, at the beginning they gave us, what was it? 1 minus 2i. So it's a positive 1. How do we write this as a factor? X, that's a positive, so we say x minus the group 1 minus 2i. X minus the group 1 minus 2i. And the other one was the conjugate version, x plus the group 1 minus 2i. Okay, so oops. Your homework tonight is the following. You have your synthetic division worksheet. I'm only giving you a couple problems that are like these. They also come from page 847. Just a couple problems. We're just doing the evens. I didn't write even on the board over there, but we're just going to do a couple problems because your main homework is the test review, which I've given you all the answers to. On the test review, it does not have anything from these honor sections, but everything we've been doing on H35 and H47 could also be seen on the test. That's not on the test review. Okay, so synthetic division, finish that. You have a couple problems that are like what we just did today. Here's the test review with all the answers. Yeah, the linear factorization is the answer.
Are we going to be asking questions like this the next time?
On the short one, the 28 through 36 next time. Oh, we didn't turn that in? I thought we turned that in. Okay, next time due is the honors 35 and honors 47. Due next time. If you have on my calculators, please go put it back in order.
Are we going to do
Sure. Okay, pass that down.